Quite unfortunately, we now have 10 minutes to get through about an hour of content. So this is a big bummer. I think we are going to need to cut a lot of corners, and I apologize for that, especially for those of you on the live stream. I'm going to direct you to the annotated code for this section, which will go into a lot more detail than I have time to do. But I just want to talk about apps and bots as techniques or tools for trying to overcome some of the weaknesses of digital trace data that we talked about in the beginning. These are some of Matt's and mine: incomplete, inaccessible, non-representative, drifting, algorithmic confounding. They're dirty or unstructured, and sensitive. And I'm going to argue that app-based research allows us, with maybe like a better alternative than just like kind of jettisoning this data. Like, we obviously can't just like not look at social media if we want to study health behaviors, right, or electoral processes or politics. So the idea is, how do we integrate them? And I'm going to argue, that as survey response continue to drop, and as many of our most important questions require longitudinal data, relational data, qualitative or text-based data, we need to have a reckoning with these techniques. And we have to remember that the positives, there are fewer positives than weaknesses at this point, but those positives are big positives. So we have to figure out how to keep the good and deal with the bad. And I argue in a lot of my work that we can kind of have our cake and eat it too. We can overcome many, though not all, of the weaknesses of digital trace data by building apps to collect social science data. So back in the Stone Age, about 6 years ago, I was developing what I called at the time social media survey apps. And my idea was that we should try to provide some kind of conventional social science structure for the free-flowing, naturally occurring data that we all want to analyze. And I developed the idea of a social media survey app as a means of both extracting the digital trace data, but then also surveying the people who produce that data about other characteristics that are not observable from the social media data. And an additional advantage, there's a number of advantages of this I'm going to run through, but the principal advantages are filling in the blind spots in our data. We know that it's non-representative, but at least now we can know how it's non-representative if we use a social media survey app to, for example, ask people about their demographics. We create a new contract with the user. We get around a lot of the ethical issues because we can have an informed consent dialogue within the authentication of the app. We can structure our data better, and very often we can ask for additional permission to access data that's not readily or publicly available about the user. So in the case I'm going to show you, we're going to look at an app I built that helped nonprofit organizations optimize their social media outreach. And in return, the app offered them an analysis of how they were doing to their peers. This simultaneously allowed me to collect the text-based data and the public Facebook data that at the time was available, and insights data, which you can think of as kind of Google Analytics. So if you've been to Google Analytics, you can see that you can track the demographics of people who are visiting a page, or maybe how often people are clicking on a page, or maybe the geolocation from which people are clicking on a page. These aggregated data can be then used to further validate things like audience structure and audience interaction with the public post that you can't see, but the owner of the, in this case, public fan page or Facebook fan page can see. So this app that I'm about to share with you both collects the publicly available data, gets a non-public form of Facebook data that includes over 100 metrics that describe various properties of users and their behavior and interaction with the website, and asks them additional survey questions to further fill in the blind spots that they can't get from either the public data or the private data. And so that's basically just what I said there. So the workflow of an app, I mean, this is a very simple template. Typically, there's some kind of user authentication. So just like when we authenticated with Twitter, you agreed to allow the app to transfer your data. If you are surveying a population, maybe you have at the end of your Qualtrics survey or the end of your Google form or whatever you're using for your survey, you ask people to give you permission to access their data. Obviously, you need to carefully prepare the the respondent to know what they're sharing, why they're sharing it, who they're sharing it with, how the data is going to be protected and used, and this is an important step, but it's one that can be clearly articulated as juxtaposed with the many arguably less ethical research that's gone on, either with just simply studying the publicly available data, which even though that data is in the public domain, the people who produced it might not know that it was in the public domain and it could be studied, and that raises a particular kind of ethical issue. Or the kind of ethical challenges created by research that occurs without informed consent by experimenting natively within the platforms, like the emotional contagion experiment. This was back when we used the term big data, apologies. But basically, notwithstanding my neologism, we've got user authentication. That then triggers an app collecting some type of data field. Then the user is redirected to a survey, or maybe they do the survey first and then come to the authentication, depending on your workflow. That survey can then get sent to some kind of cloud server where the data is stored. Then the app, if it's going to offer something back to the user, and not all apps need to do this, many people are now paying users to use apps. So large survey firms might pay people $10 to use an app that then shares their data with the research team. But if you make the data yourself, you can create some kind of user incentivized participation in research. In this case, I was trying to help organ donation groups increase the number of people who are aware of organ donation, and they were very interested in knowing how their particular organization compared to their peers and wanted to learn from the successes of their peers and avoid the negative experiences of their peers. And so this app created an audit by looking at all the population of organizations who participated in the study together and delivered a report about what they're doing well and not well. And it had the mouthful name, the viralgorithm, which is no longer live. But basically, what's going on behind the scenes is calls to the Facebook API, calls to a Google API. Those are getting piped to a cloud server, analyzed, and then in the Stone Ages, we actually emailed a PDF report, but of course now it's much easier to deliver that analysis in more or less real time using something like a Shiny app or perhaps a Flutter app, which I'm going to describe in just 1 second. The neat thing about this effort, I think, was that we were able to fill in knowledge about issues of representativeness. So earlier I was asked a few questions about what you do when you don't know how representative the data is. We're able to actually benchmark this against a census of nonprofit organizations and look at selection issues and do it, and also combine this with a kind of respondent-driven sampling. So if you build an app that's successful and people share it with their peers, then you can have a tandem sampling approach, which includes both respondent-driven sampling and some form of stratified sampling. Now, as Matt's research would show, you need to be careful and know which types of respondent-driven sampling create bias, but one can also make an argument that this scales well to difficult-to-reach populations. The interesting thing is in this first of its kind app, we got a 40% response rate, which is pretty high, I thought, even though we're studying organizational populations, which have typically higher levels of response rates to surveys, and very minimal level evidence of selection bias according to these observables that I don't have time to describe, but are in a paper that are linked in the slides. So one of the challenges of building apps for social science research, for a long time it required significant coding skills that kind of transcend a lot of the base skills that many of you may now have in R or Python, skills in creating web pages, dealing with the aesthetics, CSS, cloud computing, reactive programming, which is challenging for many social scientists. There's a competitive environment for attention, so why should someone use your app and not some other app? That's become increasingly a problem. And there's pervasive concerns about data sharing and privacy, so now there's the stigma of Cambridge Analytica, and it's a different, people have some idea of what might happen when they share their data. Although my conversations with major survey firms who are using these apps suggest that these have minimal effect on people's willingness to share data. But that's an empirical question that we need more research on. Compelling incentives are hard to identify. What can your app give that someone doesn't already have or need? And building those incentives into your app can be non-trivial in terms of the coding involved. But again, if you can afford it, and one of your group projects may well be able to afford it here at SICSS, you can pay people to use an app. So you've got a few options for building apps. One is Shiny. Shiny is an interactive platform within RStudio, hosted and maintained by RStudio, that allows one to create interactive HTML, JavaScript pages that allow users to interact with a web page. it's a relatively new tool. It's not so new anymore. An example, I'm disconnected from the internet, unfortunately, quite unfortunately, but if I were able to mouse over this chart, you'd see that I can interact with this data from Google Charts and pull sliders and move the data around. It's useful for kind of data visualization, but as I'll show you in just a second, when we get inside the guts of the Shiny app, we can embed calls to APIs. And we can ask for user authentication, and we can use that to create an authentication dialog within the Shiny app, and also to send data to a database, like a Google database, and so on and so forth. And there's examples of Shiny apps that, for example, collect Twitter data, look at mentions of Twitter themes over time, and so on and so forth. There are 3 components of a Shiny app, the global script, the server script, and the UI script. The global script defines objects that are going to be used universally across all of the code, so things like variables you might want to track in your code. Sorry I'm rushing through this, but we're running out of time. The server is actually what's the guts of the code that's doing the analysis that gets displayed in the web page that you're building. So if you were making API calls that you were then going to visualize, this would be a set of instructions about how to collect that data. The UI is the user interface script, and that explains the aesthetics, what the user is going to see in their browser. And so basically, a Shiny app includes these 3 components. It used to be you needed 3 separate files. Now they can all be in one file. And you can build a pretty serviceable app. The neat thing about Shiny is that there's a large and vibrant community of people developing Shiny apps, many of whom share their code. And this is an open source community with a lot of templates that might inspire you to work from here. By the way, I mentioned references to work on this and on sampling issues related to using apps for social science research. Those are all, I think I mentioned they're in the slides, they're actually in the markdown document or the annotated code document. You can see them there. You may say, well, I've never linked to a cloud server before. How do I do that? Well, lo and behold, there's the Google Drive package, or the Google Sheets package, which will allow you to populate a Google Sheet, assuming you've authenticated. With data. So, the neat thing is, at the outset I said, well, you need significant programming experience to do all this, but now you don't need to know how to spin up a cloud server and how to populate that and authenticate that in order to push data there. You just need to read the vignette on the Google Drive package and embed it within the server script in your Shiny app. I'm not saying any of you might do this tomorrow if you've never developed Shiny before, but it's easier than you might think. The ability, we're really getting at the point where people are building tools that make tools. And that goes for machine learning as well. A lot of the interfaces and APIs for working with, for example, neural nets in R work through R packages like Keras, which are making API calls that allow us to spin up and define and run those apps. So we are, I think, unfortunately, I've got the old slides up here. Sorry. Let me just see if I can quickly navigate to my new slides here. Apologies for that. The last thing I wanted to talk about, because I'm now the only thing that stands between you and lunch or dinner if you are in Oxford and you're very hungry because of our fire drill. Just going to quickly see if I can pull up the right data here. I think we have 2 HTML. Yeah, this is the old one, sorry. Here's the new one. Okay. So finally, I'm just going to briefly talk about bots. I also want to talk about one more thing before we talk about bots. And that is another really neat new tool. Just like Shiny is trying to make it easier for people to build apps, Google has produced a really neat tool called Flutter. So Flutter is a new development tool that can simultaneously build apps in iOS, in Android, and a web-based version. So basically, there's one development environment. Oh God, no, 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 no. So you'll see the development environment on the left. This is a code development environment called vCode. But the really neat thing is you can run simulators of mobile devices as you code. So as you tweak your code, you're actually going to see aesthetically how it appears in mobile. So if you have interest in developing mobile apps or that simultaneously scale across different operating systems and even eventually Flutter is working on, or Google is working on extending this to web, you will see a really neat opportunity to avoid building separate software for iOS and Android and so on and so forth. And combined with many of the other tools we've talked about, you can build some pretty neat apps now. We are currently developing a Flutter app in the Polarization Lab, and we're hoping to open source that as soon as possible, probably by this fall. So if you're interested in that, let me know. I can turn you on to some resources. The short story is you need a lot of it. You need getting a Flutter workflow set up might take about an hour, but that's not because it's hard. It's just you're downloading a lot of dependencies, and it's very well documented online. I think I have a link somewhere in the slides. If we get the right ones linked on the schedule, we can look at that. Okay, we're 5 minutes over. Bots is one of my favorite topics, so this is just going to be a whirlwind tour. Why bots? Well, first I want to give a shout out to one of our current participants who did some of the really creative and interesting, was part of the first wave of bot-based research, I think. This is a paper that Kevin Munger wrote that recently appeared in Political Behavior, Tweetment Effects on the Tweeted, Experimentally Reducing Racist Harassment. And here in this really neat paper, Kevin developed a avatar that was either black or white that responded to racist commentary and was able to show that when white people censored the racist language, there was a reduction in racist language that did not occur when black avatars censored the racist language. As a really neat, the paper does a number of nice things, and I encourage you to check it out. But for me, I think it's really neat in developing kind of a new model of research. Bots can do things, and many other people, many of us are using bots in, say, network experiments or network games, and people like Nicholas Christakis or Damon Centaur, or in the Polarization Lab, we've done some Wisdom of Crowds style bot-based studies where you inject a bot into a debate or into some kind of multiplayer game. But for field experiments, it's really neat because you can actually send something out into the world. Now, this raises huge ethical issues. And in a recent study in the Polarization Lab that just came out a while ago in PNAS, we built bots that exposed Republican and Democrat respondents to a large survey. We offered them financial incentives in our treatment conditions to follow bots that retweeted messages from elected officials from the opposing political party in order to study what happens when you kind of experimentally disrupt people's social media echo chambers. And this is the study I was mentioning at the outset today, where we linked the survey data to the Twitter data. And of course, we have all the rich data of interactions between the bots and who retweeted what, and mountains and mountains of data on text. We also collected daily slices of the network to try to see when and how these things scale. This can all be linked and studied in a number of ways, and our paper takes a first cut at that, showing that exposure to opposing views actually increases partisanship, at least as defined through substantive issue positions on a liberal, kind of standard liberal conservative scale. So how do I build a bot? Earlier I mentioned that there is a native function within our tweet that allows you to post a message. So if you've created a bot account, and this is a little harder than it used to be with Twitter, Tom has some recent experience here if anybody's interested in building bots, and Kevin, I think, has a new paper you might be able to share more with us about that. Twitter has cracked down on bots, and that has complicated bot-based research. But basically, you create an account, and then you can host some R code, often on a cloud server, that runs in a repeated fashion and intervenes or posts something in a targeted way. And here's, for example, a bot that would randomly retweet the last 50 tweets that mention computational social science, and then retweets one of them every 60 minutes. Now, this is trivial. This is not going to do anything for social science research, but you can imagine once we've carefully identified a population of racist tweets or of elected officials who are retweeting content that we want to expose people to, we can begin to intervene based on rules we defined elsewhere in the code. So this is really just like a template of something that could be much more complicated. This is the workflow from Kevin's paper that we don't have time to go through in detail. I just want to give you one last tool in your toolkit for hosting a bot. Many of you may not know that you can run an instance of RStudio or Jupyter Notebooks or whatever you like to use on a cloud server such as Amazon Web Services, that you can also use Google, Microsoft now. There's a tutorial linked here that I use in one of my graduate seminars that tells you how to get a workflow of RStudio working in the cloud. And essentially this allows you to either put a machine up there and let it run a bot or something like that, or to open, say, 20 instances of RStudio at the same time and run 20 different types of text analysis, or perhaps most usefully, purchasing time on a really large computer if you have some heavy number crunching task that could save you hours or days. So if you don't know how to run an instance of RStudio in the cloud, I would check this out regardless of whether you want to build a bot. They're also useful for storing data. So Amazon Web Services both has an elastic compute cloud where you might run your instance of RStudio. It also has a server system called S2 where you might serve or push your data collected by an app or a bot or whatever else you're making. Okay, so yeah, there's ethical issues in bot-based research, right? Mainly, chiefly, and I think this came up. I think I overheard a group discussion about this. If people are interacting with a bot, are you under an obligation to tell them they're interacting with a bot? In our case, we did tell them that they were going to interact with a bot. We didn't tell them what kind of bot or what the bot would retweet. Other study designs will have a bot in a model and then later debrief people telling them that they interacted with a bot. But these are some of the genre of ethical issues that come up. Also, in principle, one thing that terrified me, and one thing that inspired me when we were having discussion of ethics, we had Gary King here 2 years ago, who's for those of you who don't know, is like a leading computational social science, political scientist. And he really shared a lot of vivid details about ethical trials and tribulations in his research, when he was like, well, maybe it was unethical to roll out healthcare to one part of Mexico, but not another, and it was illuminating to me that we should all share these kind of ethical dilemmas that we come through. So when we were running our bot study where we exposed people to information from opinion leaders from the opposing political party, we didn't know if it could retweet misinformation or trolls or something like that. So I actually had a phone notification every single time that our bot tweeted so that I could manually review in the most depressing month of my life the content that was going out. But these are the kind of safeguards that I think, mountains beyond mountains that we're all trying to work out. And I was very nervous during that entire period that I might somehow mess things up even more. And here's another example of why we need to think carefully as we send bots out into the world to help us do our research. So we're 15 minutes over. Apologies for the lapse in lunch planning. The group exercise for this afternoon, I want to quickly go over for people in the partner sites. It is available on the, it's linked on the slides for on the main schedule. Basically, the idea is to break into small groups by counting off. We're going to do that in another room for folks who are here at Princeton. You're going to work for 15 minutes to identify a research question that you believe can be answered using some of the methods we discussed this morning. Identify a sampling frame to help you answer this research question. For example, if your question is about politics, your sampling frame might be a list of elected officials on Twitter like we used. Use legal screen scraping techniques in order to collect the names of individual accounts, keywords, or topic areas to populate your sample. Write code to collect data from each unit of analysis in your sample and evaluate the strengths and weaknesses of the data you collected using the discussion and the strengths and weaknesses we talked about this morning. And if you get this far, and different groups will complete the exercise or not complete the exercise, outline a hybrid research design. Don't actually build the bot or the app, but have a conversation about how an app or a bot could help you address some of the weaknesses of your study's research design. Now you'll notice that this exercise is a little more open than the one from yesterday, and that's by design. We're trying to incubate group research projects among you, both you here in Princeton and also you everywhere else, and also people across sites or further down the line. So really use this as an opportunity. These are not hard and fast rules. I want you to explore each other as researchers and as scholars. There's only one requirement that I would ask for this study, for this part of the study, which is that within each group, I would ask that the person with the least coding experience write the code. And the idea there is that everyone who has deep domain knowledge will have to vocalize it, which will help them teach, and it will help the person with less coding confidence develop the skills, the concrete skills they need. And of course, remember our principles of generosity, patience, respect, openness, togetherness. It might take time, and you might want to just cut and paste something from your old code, but please remember that other people are also learning around you, and you can learn to teach if you know this stuff already. And if you don't know this stuff already, most of the people at the Institute, broadly defined, are like you. So please insist upon slowing down the workflow. And there will be time in the beginning of next week to have much more extended and elaborated discussions about how to develop and design a group project. And we're assuming at this point that many of your lunchtime conversations or dinner time conversations may morph into broader discussions about group projects. Though, again, we'll do that research speed dating thing at the beginning of next week. Okay, so I don't have time for questions, and I know everybody here is hungry and everybody in Istanbul is sleepy, so we will see you tomorrow. And apologies again for the fire drill and assorted AV mishaps. Thank you.